Hi everyone, welcome back to our channel. Today we are going to design a Matlab simulation for an superposition theorem. So this is what we need to design. Here we are having an voltage source of 30 volts and another voltage source of 30 volts. Two sources are available and it is having an T-type network. This is first element series branch element 1000 ohm. This is 500 ohm resistor. This is an 2000 ohm resistor. So we need to develop this circuit. So just run it, you can understand how the things are happening. So input voltage is 30 and output voltage at another port is also 30, and you can see here what are the currents generated by this, and you have to verify the algebraic sum of currents. This is what we have to develop. In the second circuit, we need to activate first source, and we need to deactivate another source, and we need to find the current. And in the another source, we need to activate the first source, and we need to deactivate the another source, where this you can see here the voltage source is 0, and we want to find the current. Here you can see here this is 17 milliamperes, this is 8 milliamperes, and both if you add you are going to get 25.71 milliamperes. This is what we have to validate. So now initially let us try to develop this Matlab simulation. Okay, so how to develop this Matlab simulation is very simple. So just for reference I'm showing you this simulation. Okay, now let us try to construct this. How to construct this one is very simple. First open your Matlab. Okay, so just double click on Matlab, then you get an, so you can see here when you double click, so this is the Matlab window. Just double click on the Matlab, it will get open like this. So when the Matlab is open, it will show a window like this. So this is the window shown by the Matlab. So here, so you can see here, the Matlab is open. Okay. So now, but currently I had already turned on. That's why I'm closing this Matlab. So when you turn on the Matlab, just the Matlab window will be open, and here at the top you are going to have the simulation. Just press that simulink. Okay, just press the simulink and you'll be getting like this. Okay, so now and then just you can see here a blank model. We require an blank model. Just press the blank model. So then automatically and window will be open. Just keep this window aside. Okay, you can minimize the main window and you can keep it aside. Okay, so just enlarge it as per your requirement. And here you can see here at the top, if you keep your mouse, it will show a library browser. Just click on the library browser, then you'll be getting an browser like this. Just minimize this browser also. Okay, so then you'll be knowing what actually you require. And then the second process of starting is, so actually we need to design this network. Okay, so we need to design this network. So how to design this network, now let's try to understand. Okay, so let us try to select the voltage sources, voltage source voltmeter, and two voltmeters, and two voltmeters, and two voltage sources, and one ammeter, ammeter 1, ammeter 2, ammeter 3, and we'll select the elements. Okay, so where to go is just to go to this simulink. You can have multiple options here. So in these options you can select the first block. You can see here simscape. Just press simscape. From simscape you just press electrical. Okay, so here you'll be getting electrical. In this electrical, just very simple simscapes electrical to specialized power system. So actually now I'm using 2019b. Version by version it will change. Currently I'm doing by Matlab 2019b, and here you will be seeing here fundamental blocks. What we require is, in fundamental blocks, just drag the power GUI. Okay, it's very important to run the simulation. And electrical sources, what kind of source we require is an DC voltage source, like the DC voltage source. And we require, so with this what DC voltage source is completed, and again come back. Okay, so and we require some elements. Okay, so what kind of elements you require is series. You can see this branch, series RLC branch. Just drag this branch also and just to go back. and then you require measurements. Okay, just click on the measurement. We require one ammeter and one voltmeter. Just bring it out and just minimize it. Already you're very clear that how to construct it. Just enlarge it, and you can see here what actually we require is this is what the simulation circuit we need to design. So we require, so first we try to design the network, voltage sources and three resistors. Three resistors should be connected in T network. Okay, so first double click it and see that you require only R. Just keep R and just apply it. Just press OK. So here it will show series RLC branch. And now what is the series RLC branch? As per the circuit you require is first one is 1000 ohm. Okay, so here you define the value is 1000. Okay, 1000 ohms. Okay, and just apply. And here also if you want to write down, here you can apply the value of this resistance is 1000. So this is 1000 ohms, and I want an T network. Just take another element, just use Control C and paste here. Okay, so again Control V, so you'll be getting three elements. I want to reverse this, so here you can see here, just press this and use Control R, it will rotate. Okay, now it is rotated. So initially you can see the diagram how much you require: 1000, 2000 and 500. Okay, so now this value should be 500. Just come here and just type 500 and just press on apply and OK, and you can see here, so this will be acting as an 500 ohm. And next one, here you require 2000. Okay, just write down 2000. Okay, and here this value is 500 ohm. This is also 2000. Just double click it and just change that value as 2000 and just press apply. Okay, so this is how we constructed the T network. And now we have to apply the voltage at input port, and just use Control C, and here just use Control V, it will get pasted. Okay, so now you require an voltage. Later we will connect this voltmeter as well as the ammeter. Okay, so now let's try to give the initial connection. Just drag it and just connect to this resistor. Automatically it will show you in black. If it is showing in solid black color, indicates that the connection is successful. And from the negative you connect to the another end of the resistor. Okay, so just you can pull it out like this also. And next from this end to this end you just connect, so it will show that value is correct. And here also you may connect like this. Okay, and next one, the positive end of the battery voltage source you connect to here, and from negative end you try to connect it. That's all, you have been given the connections. Okay, so you can just verify the value. 1000 ohms T network is, this is a 500 ohm, this is 2000 ohm. Okay, let's try to make it larger. Why? Because voltmeter ammeter we need to add. Okay, and just drag it like this. Okay, so you require a continuous power GUI. So here we want to measure the, see how much voltage we are applying. Just use the positive button and connect to the positive, and use the negative button and just keep it on the negative terminal. If it is showing in solid black color, your connection is successful. Okay, so now I require one more ammeter and voltmeter. Just copy the voltmeter, use Control C and here Control V, and from this positive terminal connect to positive, and from this negative terminal connect to negative. Okay, so you can drag it and you can design it however whatever you want. Okay, so now we want to keep the outputs. Okay, so in this branch I want 1 ammeter, in this branch I want 1 ammeter, in this branch you can see the diagram, so where you're getting confused. So here 1 ammeter, another ammeter as well as the another ammeter. You can see here the current flows only in this direction, here the current flows only in this direction. Okay, and here the current flows in downward direction. Okay, so now I want to keep an ammeter. That's why first remove the connection and move the ammeter to here. Okay, so when you move the ammeter, so this is latest software, whatever the errors are it will generate of its own, no need to bother. So pull it out and and you can see here the connections. From positive terminal you connect to the voltmeter, and from negative terminal you connect to here. Okay, same ammeter you control C use and remove this block and just press delete button and place the ammeter here, control V. Okay, you'll get ammeter, but current flows from top to bottom. So this should be an positive. Just rotate it. Control R. Okay. So when you rotate it, the positive will be connected to this point, and negative will be connected to the element. Okay. So with this ammeter connection is completed. The source is from this side, and current flows from in this direction. Okay. This should be an positive terminal. Therefore, remove this connection and use this ammeter. So just to copy it, Control C, Control V, and just you see here it have to rotate. Use Control R, it will rotate. Okay, so this is the direction. So the entering direction will be positive. Just connect to positive, and leaving direction is negative. Just connect to negative. Just move it up if you want to make it more beautiful. Okay, so now I want to see how much voltage I have to apply. I want to see the output. So this for again you can see the tab browse library browser. Just click on the library browser. Here you require the output measurement. Just scroll it up, and here you can see here sinks. So press on the sync button, uniquer and display. Take out the display. Okay, so I can drag out the display. So now display is available here. So use this display to connect. Okay, I want to measure the voltmeter. Just you see here, just keep it in a straight line, automatically it gets connected. And similarly you copy the multiple displays across the voltmeter ammeters also. Okay, so this just by watching you'll not get, just do parallelly, then you can understand. Okay, and copy this display again, Control C, and here Control V, and here also Control V, and here also Control V, and here also Control V, and connect the output current to this side, it will get connected, and connect the output to here, it will get connected, and here also the current block is just connect here. So if the connection is correct only, it will show in green, red, solid color, black color. If the connection is wrong, it will not show any other color. And again, you can see here, if it is straight line, just click it, it will get connected. Okay, so this is how the diagram resembles after connecting. So, and you can see the original diagram, what we need to construct. This is the diagram we need to construct. We want to apply voltage of 30 here, and here also we want to apply a voltage of 30. Okay, so see that, double click it, and it will show the amplitude. It is nothing but 30. Just click apply button and just click OK. Here also you have to apply 30. Just go to the amplitude and keep the amplitude as 30 volts, and just click on apply button and OK button. And now just you can see here, before you run you should have a continuous block here, which is nothing but power graphical user interface block. Just run the button here. Okay, at the top you have an run button. Just press the run button. As soon as you press the run button, here you can see here voltage we applied is 30 volts, and voltage here we applied is also 30 volts, and these are the currents in which flows in this direction. Okay, so the current which flows in this direction is nothing but 17.2 milliamperes, and current which flows in this direction is 8.6 milliampere, and the current which flows in this direction is 25 milliampere. So now you are getting doubt whether what is the amount of current. So in order to solve this problem, just we can use one multiplier such a way that you will get a clarity. So for this, just you have to go to again the, just double click on the library browser, and just go to here, you can see here commonly used blocks. Okay, in the commonly used blocks you have a gain. Just drag out the gain. Okay, so then you'll get the gain. Okay, so just remove this connection and use the gain here. Okay, just you can drag it like this and connect the output current to the gain, and from the gain. So here this is directly amperes, but I require in milliamperes. So this value I have to multiply with 1000 and divide with 1000. Okay, so when I multiply this value with 1000 and divide by 1000, automatically what happens here is hello, and now the current flows from this direction to this direction and from this direction. So here this value is to be multiplied 1000 times and divided by 1000 times. So in order to do it, so in the multiplication I'm going to use the gain value as 1001 0 0 0. I'm multiplying with 1000 and the answer will be in milliamperes. Just use apply button and just save it and just run the button. Okay, you can see here. So when you multiply this gain with 1000 times, I'm available current with 1000 and divided by 1000. Okay, so automatically it will be get connected into milliamperes. Okay, so this is very simple technique of conversion. Okay, so you can see here how this simple technique will work. So in the conversion. Okay, so for example, we have been obtained the, we will try to do for the another block also. So here you can see here. So this is 0.025. Okay. So 0.02571. Okay. So you can see this current value. Current value is 0.0257. So here what I'm going to do is, in order to convert into milliamperes, multiply this with 1000. So this we are trying to put like an again block and divide by 1000 such a way that the value. So here I'm using this Glen block and how many zeros are there? 3, 1, 2, 3. So this will be 25.71 and this 1000 is there, no, it will come to numerator and this will be written in terms of milliamperes. Okay, so this is how we are going to get the block. So in order to convert this into milliamperes, what I have to do is just multiply with 1000. Okay, so I'm multiplying. So this simulation value I'm going to use again and I'm multiplying that value and it will be converted into milliamperes. Similarly, just control C, copy this one and remove this link and move this and just use control V button, just copy it and paste here and just connect it. And just once again connect the control C, the gain value, and you can use in this connection also. Just delete it, control V, and just use this button and just use control R. It will rotate and you are going to get the value like this. And here the output you connect here. Okay, see here these values, I mean this is 0.0571, no, so this what you're going to do is you're multiplying with 1000, that's why I'm writing this multiplied and resultant answer will be in terms of milliamperes. Okay, just run it. Here you can see here the current when source 1 is activated and source 2 is activated, 30 and 30 I applied, how much amount of current is flowing in this block is 25 milliampere. So now in the first step we are activating only this source and this source we are going to deactivate. In order to perform it, just copy this complete block and use control C button. So this is the diagram. Okay, let us try to see here. I'm going to move this diagram down to write down the comment. Okay, so here we are going to write down when both sources are activated. When both sources are activated, that is V1 is equal to 30 comma output port voltage is also 30 volts. Okay, so this is what we are going to get here. Okay, so you can enlarge it and you can copy it here. So size you can keep it bold, so just copy and keep the size black, bold, and size as some 18. Okay, so when both sources are activated, just again copy the same content, control C use and just scroll it down. Then you can see here, so just paste as control V, then you can get the diagram here. So here we will be activating only one source. You can see the original diagram what we need to design. So here also both are activated and we have been obtained as 25 milliamperes, and just move it down, and here you can see here first source is deactivated. Okay, so input source is deactivated. That's what we are also going to make. Input value we are going to make it as 0. So this I have to make it as 0. Just double click on this button and enter this value as 0, and just press on the apply button and press OK button. Okay, and just run it. Okay, here you can see the beauty. So whenever this source is of 0 and this source is of 30, and this is only the leading, the current will flow in this direction, and current in this branch is 12.86 milliampere, and this is 8.5 milliampere. Okay, so initially if both are activated, here it is 25 milliampere, but here it is only 8.5. The same again you copy here, just use control C button and come down of simulation, just use control V button. Here you will be getting, so here V1 we will keep it as 30, and V2 will keep it as a 0, and as per this you have to load this value. Double click on it and enter this value as 30, and just press on apply button, and here also just double click on this voltage source and make it of 0 magnitude, 0 volts. Just apply and just click OK, and you can see here now this source is active, this source is deactive. So that's why I kept an scope also to understand well. Just run the button, automatically you can see here it is of 30 and here it is of 0, and only this source is activated and this is deactivated. Just again run the button, and here you can see here you are getting this source is active, therefore this is positive, and current here it is negative, and the current, the branch which flows in 500 ohm is only 17 milliamperes. 17 milliamperes plus 8 milliamperes. Okay, so 17 plus 8, you are going to get approximately 25 milliamperes. This is how to verify the superposition theorem. So just by observing this video, nothing you get, just you have to do it parallelly. So just run the YouTube and just pause the video, and you can do it parallelly. Okay, so if you feel my content is good, just give an like. I will do the more simulation on subject on electrical circuits related to our lab. So if you feel the content is useful, just please give a valuable like and share with your friends. And if you have any doubts, let me know in the comment section. I will answer. And kindly subscribe to my channel and kindly encourage this channel. This is a free channel for the development of students as well as for faculty. So thank you for watching patiently. We'll meet in another simulation on one more analysis. Thank you for your time. We'll meet in the another video.